Take a look at the same idea then, but with a little bit more complicated function. It's slightly more complicated. This is not just going through zero, a straight line going through 0, but it's going to be a straight line going through -5 as a y-intercept. And then we're going to apply the absolute value to it and see what that looks like. So as I graph my original function, okay, I'll graph it in red, -2, -7, right about there, 0, -5, 2, -3, 4, -1, and 6 over 1 up. Okay, so it's going to be a straight line that looks like that. Okay, so as I apply the absolute value, -2 into here becomes -2 minus 5, which is -7, and I'm going to apply the absolute value, so it becomes +7. So -2, 3, 4, 5, 6, 7. Okay, so that means that that coordinate there has been reflected or folded up there. 0 is going to be -5, absolute value is 5, so now that y-intercept is no longer down here. Okay, the 2 is going to give us -3, which is +3, so again it's going to be, that point is going to be reflected up there. The 4 is -1, so it's going to be +1, so now it's going to be 4, +1. So basically this graph is behaving like this linear function until we get to, again, the boundary, because when we put in 6 we get 1, so 6 over 1 up. Now the boundary point of it being equal to 0 is where we're going to have the change, whereas the inside is equal to 0 is when x is equal to, maybe I'll choose a different color here. Let's choose, I'm just going to choose that color. Is when x is, or that's black. So when x is equal to +5 is when the inside is equal to 0. And that then represents our boundary point. Okay, so it is going to behave one way on this side, and it's going to behave differently on this side. In fact, we know on the right hand side it's just going to behave exactly the same as the original function. On the other side though, where the y was originally negative, it's going to behave differently because that we did something, the absolute value did something to it. And it just folded. Essentially it's actually taking that point and folding this graph up here. It's actually called a vertical reflection. So we have two different behaviors here, and essentially it's two different functions. And we can describe this now with a piecewise function. So just like we did before, we described the positive and negative versions of the expression, and they had domain boundaries, they are reflected here in the graph as well. So where the domain gives us negative values, it's going to behave like this line here. In fact, it's got a slope, instead of slope of 1, it's got a slope of -1. Okay, instead of y-intercept of -5, now it has a y-intercept of +5. So essentially this is a linear function that we can describe when the inside is negative. This is a linear function that can be described when the inside is positive. In fact, it behaves exactly like that. So, how do we describe this as a piecewise function? Well, it's the same as what we did before. We need to establish when the domain is positive. So inside equals positive. And we need to know when the domain is negative. So inside equals negative. And again, our boundary, remember, boundary is going to be based on x equals 5. So then I can establish my domain boundaries that way. So when the inside is positive, when it's bigger than 5. And I can see on my graph, yeah, it's bigger than 5, and I'm going to put the equal to with the positive version. And when it's less than 5, when x is less than 5, okay, on this side, yeah, it's going to be the inside was negative, so it behaves this way. So then I have to write the behavior of those graphs. So when the inside is equal to 5 or greater than 5, the graph is going to behave just like the original y equals x minus 5 graph. So what happened on this side? Well, it's very similar to what we had to do with the expression. Well, if the inside is negative, I have to make the inside positive by using the opposite. And it's going to behave like this. And let's just double check, because we know how to interpret this graph. This is a linear function, y equals negative x plus 5 when I expand this out. And in fact, does this green line reflect a slope of negative 1? Yep, it does. And a y-intercept of positive 5. It does that as well. So this is consistent with what we see. And for this domain, although the domain stops here, because remember that's only for when x is less than 5, it's going to be this straight line, negative x plus 5. And from this boundary point to the right, or the domain is bigger than or equal to 5, it's going to just behave with slope 1 and y-intercept of negative 5. So if I just trace that back, my original function, yeah, there it is. Okay, got a y-intercept of negative 5. Okay, so this is how we describe the function as a piecewise function. It's very much the same as what we did before. It's this idea of positive and negative. And again, going back to the original idea of when we go backwards through the absolute value, we have to consider a negative version of that and a positive version of the inside.